Hi everybody, this is Mrs. Costello. I am doing the day 2 video. This is called composition functions. So the big thing on this one that I tell my students when I teach this, in regular times in person is you need to work inside to outside. So I'm going to write that right here. And if you want to use that, then that would be awesome. So work inside to outside. Perfect. Now, what exactly does it mean when we're doing a composition of functions? What we're doing is we're taking one function and plugging it into the other where the x is. So that's what we're going to write right here. Plugging one function into the other where x is. Right. Cool. Now you will see this many different ways, but they all mean the same thing. So where it says notations, I'm going to kind of zoom in a little bit. Okay. So this first one means like you are taking g of x and you are plugging it into f of x wherever the x's are. So if you want to write plug in to f below that, I think that's super helpful. Okay. This next one where you have, it almost looks like a multiplication symbol, but it's an open circle. This just means f of g, like you're going to hear that. So f of g. And that just means like you're going to take g and plug it in for f again. Okay, same thing. These guys are kind of interchangeable. So if you want to write that down, that would be a good idea as well. You might have something super crazy like this next one where you have h of f of g of x. And we're going to write exactly what I said down. So I would kind of do them, like I said, work inside to the outside. So you'd start with like this first. You'd do g into f, call it good. Then you do that whole thing into h. So h of f of g of x. Again, kind of crazy. But we'll do a couple and hopefully it'll start clicking. So, all right. This last one, what you have to do is you have to do g of f first. Then the next thing you do is you plug in 1 for the x's. And again, I'm going to go through some examples, so you won't be like totally on your own. So we'll go through them. We'll kind of clarify, hey, this is what's going on. You do have one more blank before we really get into it. And that last blank just says, if you have an even radical function or a rational function, you have to rationalize the denominator. So go ahead and put that in there. So here's what your whole box should look like. So if you need a second to pause your video and fix it, go for it. Otherwise, let's keep rolling. Okay, it says to find the following composite functions. So we are using these functions for 1 through 6. Now it wants you to write the domain of the new function. I think it might be a good idea to write the domain right now before we start doing our compositions. So I'm going to use different colors for each one, and I'll kind of refer to them as their colors. So I'm going to use pink for f of x. F of x is x plus 1. That is just a linear function. Oh my gosh, it's not looks like that. Hold on. It's the iPad's fault. Okay, it looks like this. That means that my domain is going to be all real numbers. So I would write that down because if you end in a linear function, you know it's going to be all real numbers. The next thing you have is g of x. We're going to make g of x blue. G of x is a rational, and your domain is always, the denominator can't be this. It can be literally any number, but it can't be that. So x cannot equal 0 for my domain. The next one we have is h of x. Let's make h of x green. H of x is a parabola. Okay. Parabolas have a domain of all real numbers as well. And we also have j of x. Let's make j of x purple. J of x is a radical function, and I know that this is like my x changes in the x's, so I know I'm going to go over 5. I'm going to start at 5 to the right. So my domain is going to be 5 to infinity, or x is greater than or equal to 5. So I might refer back to this, like if it kind of ends up looking like this, or has any parts of this, that might be really helpful. So here we go. All right. My first one is saying I want to take f of x and I want to plug it in for x in my other one. So I'm doing f of x both times. So what I would do is I would write f of x equals, right? We're going to work inside to outside. So I'm going to take f of x right now as x plus 1. Okay. What I'm going to do is I'm going to plug this whole thing in to my other f equation where the x plus 1 is. And I know that I have to, where the x is, sorry. I know that it's the same, so I'm just going to write x plus 1. And this is the x where I plug in. So I'm going to write this whole thing in where the x is. So x plus 1 plus 1. Combine your like terms. So this is x plus 2. And they do want the domain. Now that's my answer, but my domain is going to be all real numbers because this is still a linear function. Okay, so we are good to go. Number 2, f of g of x. So this is the first one where we are working with two different functions. So the first one I'm working with is f of x, but I'm going to take g of x and I'm going to plug it into all of the x's in f of x. Now it might be helpful to write down what f of x is. So f of x is x plus 1. We worked with it earlier. Now this x right here, I am going to take the function g. Oh, I'm using the wrong colors. I am so sorry. G is blue. My bad. So I'm going to take the whole g of x function, which is this guy right here, and I'm going to plug it in where the x is. So here's what I have left, right? F of g equals, I hit the circle, so I'm going to plug in my g, which is x plus 5 over x plus 1. Now, I'm fine if you leave it like that. You might have to check with your algebra teacher on what they want, but I'm okay with it being left like that. The only other thing you could do is maybe make common denominators, but it really just depends on what your teacher's feeling. So, when you're looking at your domain, the main thing that you look for is where the x's are. And the x's right now are in a rational, so we're going to see, okay, what can the denominator not be? The denominator is not allowed to be 0 on that one. This is very challenging, so I hope you're kind of getting the hang of it. If it's a little tricky, it's okay. All right. Number 3 is h of j of x. So j of x was purple. I had to look back for my colors. And h of x was green. So I'm going to go ahead and write h of x out. So h of x equals x squared minus 3x plus 10. So I'm going to take all of j of x and plug it in where all the x's are in the h of x. Okay. Here's what my new equation looks like. Okay. I have h of j of x. Now j of x was square root x minus 5. I am squaring it. And then I'm putting the rest in. So minus 3 times another x. So I am going to put in another x minus 5. And then a plus 10. Okay. So we do need to simplify this as much as we can. It's not going to simplify to be very pretty, so I apologize. I have to distribute this squared. So h of j of x equals, that radical is going to go away. So I have x minus 5 minus 3 times, because technically you're distributing it, but it's a radical, so you can just leave it. Radical x minus 5 plus 10. Okay, let's combine some like terms. The only like terms I really have are this 5 and this 10. So h of j of x equals negative 3 radical x minus 5 plus 5 plus x, because there's another x in there. It doesn't matter what order you put them in as long as they're there. Okay. Now, if you need to check your calculator for the domain, that's fine. Really, this is kind of your clincher on like what the denominator's allowed, or what the domain's allowed to be. So we're going to go off of that. And if you go back, like our domain on the x squared minus 5 was 5 to positive infinity. So I'm going to go ahead and write that, 5 to positive infinity. All right. Let's go ahead and do number 4. Okay. Number 4, same thing, but I kind of want to go through this one just to prevent some common mistakes from happening. So I'm taking f of x, which was x plus 1, and I am plugging it into h of x. Pretty sure h of x was my green one. So h of x was x squared minus 3x plus 10. So anywhere there's an x, I'm going to plug in x plus 1. So my new function is going to be h of f of x equals x plus 1 squared minus 3 times x plus 1 plus 10. Okay. So you will have to, you can't just distribute this positive. You do have to write it out twice, and you do have to FOIL it or multiply it out. Just for time's sake, I am going to skip that step. Okay, so h of f of x equals x squared plus 1 squared is x squared plus 2x plus 1. Now I'm going to distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And then we still have our positive 10. All right, combine our like terms. So h of f of x equals, there's only one x squared, and then you have 2x minus 3x, which is negative x, and then you have 1 minus 3 plus 10. 1 minus 3 is negative 2, plus 10 is 8. That's my function. Now my domain, this is a parabola because of the x squared, so I know that my domain is going to be all real numbers. All right. Cool. I think that is plenty of me talking, so I feel like it's your turn. Go ahead and pause your video and do number 5 now. All right, here's my work on number 5. This one wasn't bad. I just had to plug in f of x in where the x was in j of x, and x was inside the radical. Plugged it in, combined my like terms, and I got square root x minus 4. And then my domain is going to be 4 to positive infinity, or x is greater than or equal to 4. All right. Now, number 6, we are going to kind of do together. And the reason why I say kind of is it looks really intimidating. But look at the inside. The inside is j of f of x. Pretty sure I already did that, right? In this last one. This last one was j of f of x. So I don't actually have to do the work to find j of f of x because I already did it, right? J of f of x was this right here, this x square root x minus 4. Now this is what I'm going to take and plug in to h. Let's write down what h is. H of x is x squared minus 3x plus 10. So I need to take this whole thing and I need to plug it in where the x's are. Honestly, I think you can do it. So go ahead and pause your video and finish number 6 now. All right, here's my work on number 6. So this is pretty much where I simplified it to -3 radical x minus 4 plus x plus 6. And that is totally fine. If you plug it into your graphing calculator, pretty sure your domain is going to be 4 to infinity. So you should be good to go on that. If you have any questions, you can ask your teacher in class tomorrow. All right, so we hopefully mastered the compositions. If not, don't worry, we are going to work on it. So we are going to work inside to outside. If you want to do like g of 9 first, you can. So honestly, that's kind of the way I would approach it, is like inside it says g of 9. So I would look at g, and we have a new set of functions. So g is right here. And I would take g and I would plug in a 9 wherever you have an x. So I'm going to find that first. So g of 9 equals square root 9 plus 5, right? Now, square root of 9 is 3. So g of 9 equals 3 plus 5, which is 8. Okay. All right. Now, what we're going to do is we are going to take h of x, right? We're working inside to now the outside. The outside is h of x. Here's h of x. Okay, we are technically plugging in h of g of 9, wherever the x's are. So I'm going to write out my function, x squared plus 2x plus 3. Now, anywhere there's an x, I am going to plug in an 8, wherever the x's are. So now I have h of g of 9 equals 8 squared plus 2 times 8 plus 3. Okay. If you want to put that whole thing in your calculator, it'll just spit out the answer, which is pretty sweet. If you don't want to put it in your calculator, here we go. H of g of 9 equals 64 plus 16 plus 3. And that's going to give me 83. So that's going to be my answer. Again, this is how I would do it, because then you don't have to worry about like plugging in massive things. I really think it's easiest if you just like evaluate first and then plug in. That is my own opinion. You can do whatever you want. So, all right, let's look at 8. We'll do 8 together, and then you guys are going to do 9 on your own. 8 is in a weird notation, but we can still roll with it. So when you're doing your inside to outside, I know it's in that of notation, we really do the second thing first. So we're going to do j of 4. We're going to group those together first. So j of 4 equals, well, this is j right now. J is 1 over x. So 1 over, plug in 4 for x. That's not bad. That's pretty easy. Okay. Now, I know you're looking at this and you're going, wait a second, but I have to plug it into g of x. And g of x is not as nice, right? So I'm going to be taking my 1/4. I'm going to plug it in for x again on g of x. So g of j of 4 equals, my function for g of x is square root x. So square root 1/4 plus 5. Sorry, I need to write the x. My bad. I'm jumping ahead. Okay, I know it helps you guys. So I'm plugging in the 1/4 where the x is. So now I'm going to write g of j of 4 equals square root 1/4 plus 5. Luckily, 1/4 is a perfect square, right? 1/2 times 1/2 is 1/4. So g of j of 4 equals 1/2 plus 5, okay? You can make common denominators. You can make it a decimal. I honestly don't care, but you might have to check with your teacher. So 5 plus 1/2, I know is 5.5. Or if you made common denominators, it's going to be 11 over 2. I know I skipped a bunch of steps, but these problems kind of take a long time, so I am skipping some of the easier steps. Okay, I think you're pros now. I think you could totally do number 9. I'm going to show my work, so when you're done, you can unpause your video and see my work. So go ahead and pause your video now and do number 9. Here's my work on number 9. I didn't realize it was like a 3-parter, but honestly, you guys got it. So you start with h of x first and you plug in 1, which is what I did, and we're right here. I got 6. Then I worked with f of x and I plugged in the 6 where the x was because that's what I had gotten earlier, right? We are working inside to outside, so you kind of go like backwards. Eventually I ended up with 7 because I got 4 when I plugged in to f of x, and then I plugged that 4 in to g of x and I got 7. Again, if you have questions on this, please feel free to ask your teacher in class. I'm trying to keep the video short. I apologize. No, I'm not doing very good. And I know my students complain about long videos, so I'm trying to help all you guys out who do not have me. All right. So, we love word problems. Yes. I asked you like you're going to answer me. Anyways, you toss a pebble into a pool of water and you watch the circular ripples radiate outwards. You find that the function r of x equals 12.5x describes the radius r in inches of the circle x seconds after it was formed. And then you have a new function. You have a of x equals pi r squared, right? Describes the area of the circle with a radius x. So it wants to know what exactly a of r of x means, okay? In this situation, it is saying that like the radius is growing, right? And so that means that the circle is growing, because that makes sense. If you throw something into water, the initial splash is going to have like a really, really, really small circle, and then it's going to get bigger, right? Because that's what the ripples do. So really it gives the area of the circle depending on the radius of the ripple. Okay. Right. So we are given a couple examples where we have to actually find a of r of x. So it wants to know what the area of the circle is after 2 seconds. So I have to actually find a of r of x first. So that means I am taking all of r of x and plugging it in where the r is in the area, because my radius is what's changing. So really, well, actually, a of r of not x, but actually a of r of 2, because x was the time. So why don't we go ahead and find r of 2 first? So instead, let's do r of 2 equals 12.5 times 2, right? Because I have that radius function. Well, 12.5 times 2 is just 25. So if I'm going to find the area after 2 seconds, I am going to plug in 25 for r in my area function. So a of x equals pi times radius squared, which means I'm going to plug in 25. So pi times 25 squared, which gives me 625 pi inches squared. Or if you used the decimal, which I'm not a huge fan of decimals, it is 1,962.5 inches squared. Okay. All right. Now we're pretty much doing the same thing on C, except we are finding the radius after 5 seconds. So instead of, I want you to look at your above problem. Instead of using 2, I want you to do r of 5. And I think you could finish C out. So why don't you go ahead and pause your video and finish C. All right, here's my work on C. So you should have gotten 62.5 on that radius and then plugged in 62.5 into your area equation. If you left it in terms of pi, you should have gotten this, 3,906.25 pi. Or if you left it in decimal form, wow, that is disgusting, 12,265.625 inches squared. Okay. Again, if you have questions, you can ask your teacher tomorrow in class. All right. Now, we want to find the radius of a circle. So now we're doing something totally different. We don't know our radius. So if we're plugging this in, like usually this is our area, right? And we would solve for our radius. But in this situation, our radius is ever changing, right? If you go back to the top, this is technically our radius, breaking out, space pen. So my radius is 12.5. So when I plug in to my area equation, when I plug into A equals pi r squared, this is what I need to plug in for r. This is what I need to plug in for the area, and we're going to solve. So we're going to write 15,625 pi equals pi times 12.5 squared. Okay. Here's what you could do. You could totally divide out the pi, which makes things nice. Okay. I just wanted to show you that because sometimes people get confused because they don't realize you can do that. So 15,625 equals 12.5 squared. So I'm actually going to do that. 12.5 squared is 150. Oh, there's an X right there. My bad. 156.25 x squared. Okay. Go ahead and divide each side by 156.25. Divide by 156.25. That's actually going to be 100 equals x squared. And we get to wrap this up really nice. Square root of 100, which is 10. Okay. So that is all I have for you. I know some of those last ones were a little speedy, but I was looking at the clock going, oh my gosh, I need to speed up my video. So if you have questions, feel free to ask your teacher about them in class tomorrow. Otherwise,